Hello, my dear friends. So, welcome you all again to the second lecture based on our Z parameter. Okay, so in this lecture, we shall be discussing one more example. Okay, so in previous lecture, we have discussed a very simple basic example of how Z parameter analysis method and to how to find Z parameter. Okay, so in this lecture, we are going to consider one somewhat complicated example. Okay, so Z parameter we are going to find out, and the example, let us say example number 2. So let us take this example. So let us say this is nothing but the circuit diagram given to you people, and you have been asked to find out the Z parameter for this circuit. Okay, so let us say this is nothing but 10 ohm, all the resistors of 10 ohm. Is that fine? Okay, fine. So step number 1, okay, over here, to find out Z parameter we need to simplify this circuit first. Okay, okay, fine, we'll go by traditional method in order to find out Z parameter. Okay, and then we'll go for simplest method. Okay, so let us say this is nothing but my method number 1. Okay, so let us go for method number 1, and then we'll go for the method number 2. Okay, fine. So step number 1, what is our step number 1? You need to write the equations. So v1 is equals to z11 I1 plus z12 I2, and v2 is equals to z21 I1 plus z22 I2. Is that fine? What is step number 2? Step number 2 is nothing but to find first two parameter z11 and z21. We set I1 I2 is equals to 0 by open circuiting port 2 2 dash. Is that fine? Okay, so let us redraw the circuit diagram. This is nothing but my circuit diagram again. So now I2 will not be in picture because we have made it 0. Okay, V2 will be there. Okay, so V2 is nothing but a drop across this 10 ohm resistor. Is that fine? Great. Now there is no connection right now. This is nothing but open circuit. No, this is not there. Okay, so this is open circuit. Is that fine? Okay, and this is I1, this is V1. Okay, now let us do the simplification into this circuit. Okay, so this 10 ohm and this 10 ohm, they are connected in a series form, right? So therefore the circuit is going to get modified as like this one. So 10 plus 10, it is going to become 20. Okay, is that fine? So 20 ohm, this is nothing but a 10 ohm. Is that fine? And now again we need to go for simplification. Is that fine? So the modified circuit diagram will be having this parallel combination. Okay, so 10 multiplied by 20 divided by 10 plus 20, how much will be the value? Okay, again the parallel combination we are going to reduce, and we'll have, this is nothing but my simply a resistor. So let us say this is nothing but R equivalent is equals to 10 into 20 divided by 10 plus 20. So calculate this value. Let me calculate this value. So this is coming as 6.67. Okay, so this is coming as 6.67. Are you getting it? Ohm. Okay, so finally this is my final circuit diagram after modification. So 6.67, let us say, ohms. This is nothing but I1, this is nothing but V1. Okay, now let us apply KVL to this circuit. Okay, so after applying KVL to this circuit, I'll be getting V1 is equals to 6.67 I1. Is that fine? Okay, and then let us take that I1 to the left hand side. So I'll be getting Z11 as 6.67 ohms. So this is nothing but my Z11. Are you getting it? So I've got this as 6.67 I1. Is that fine? Okay. Now what we need to do, we need to find out the drop across this 20 the drop across this 10 ohm, right? And that is nothing but my V2. Yes or no? In order to find out that drop, what we need to do, we need to find out I1 in such a way that, okay, we need to find out I1 so that I'll be getting so that we can apply a current division rule, and then I can find out the current flowing through this 10 ohm resistor. Is that fine? Okay, fine. So let us apply current division rule. Okay, so I1 is the current which is coming up to this point, and then it is going to get splitted, let us say over here. Let us say this is I20 or I10, let us say. Okay, because they are in series, so that's why the current flowing through that particular, this 10 ohm and this 10 ohm will be same. Isn't it? So let us apply current division rule in order to find out I10. Okay, because we need to find out the drop across this 10 ohm resistor, and that will be my V2. And once I am going to find out V2 in terms of 10 multiplied by I1, then I am going to easily find out what is Z21. Are you getting it? So in order to find out Z21, what we need to do, we need to apply current division rule to find out I10. So I10 is found out like this. Okay, so total supplied current is I1 multiplied by opposite resistance. So let us say this is nothing but my opposite resistance, that is 10 ohm. Okay, divided by the total resistance. So now total resistance will be what? 30 ohm. 10 plus 20. Is that fine? So let the I1 will be as it is. Okay, so I1 into 10 by 30. So it is, let us say, 1 by 3. So I1 is nothing but I1 into 0.333. Is that fine? So this is nothing but my I10. Okay, so okay, how to find out drop across this 10 ohm resistance? 10 ohm resistors is nothing but V2 is equals to 10 into this I10. Are you getting it? Because the current flowing through this 10 ohm is nothing but this. Is that fine? So 0.33 times of I1 is nothing but the current flowing through this particular 10 ohm resistor. So the current flowing through that 10 ohm resistors multiplied by the resistor will be giving you the drop across that particular resistor. So V2 can be found out 10 into current flowing through that resistor I10, that is nothing but I10. Okay, so this is nothing but my giving me a value as, so I am going to put that I10 as I1 into 0.3. Are you getting it? And now let us take this value of let us take this I1 to the left hand side. So therefore V2 divided by I1 is equals to 10 into 0.33 will be giving me a 3.33. Okay, so let us take this one more 3. Okay, and this is giving me Z21. Are you getting it? I hope you understood this. Yes or no? I hope you understood this. If not, just recall this, or let us repeat this. Okay, we have applied, why we have gone for this simplification? Okay, why we have modified this circuit? Because we need to find out, or we need to modify this circuit so that we can get the simplest form of that circuit. So that's why we have gone for the series parallel combination reduction, and then we have found out a simplest circuit. Right over here we have found out that simplest circuit. Okay, so these two 10 ohm resistor were connected in a series, because this is nothing but disconnected from the network, that is nothing but open circuited. Okay, and that series combination of 10 and 10 will be resulting as 20 ohm, isn't it? So series combination is simply addition of two resistances, right? And then that series combination is in parallel with this 10 ohm resistor, right? So therefore this 10 ohm and 20 ohm parallel combination, we have found out its value, and that value is nothing but 10 into 20 ohm divided by 10 plus 20, and that value was resulted as 6.67. Okay, and from that we have drawn that particularly final circuit. Is that fine? Okay, now we have found out that V1 is equals to, or simply we have applied KVL to this particular circuit, right? We have applied KVL to this particular circuit, and therefore V1 is equals to 6.67 I1 was the equation, right? And once we have taken this I1 to the left hand side, we have got this Z11. Now what is our interest? We need to find out the drop across this 10 ohm resistor. Okay, so the interest was to find out V2, isn't it? So the interest was to find out V2. Okay, over here, so we need to find out V2. How to find out V2? V2 is nothing but the drop across this 10 ohm resistor. Okay, how we can find out the drop across this 10 ohm resistor? Simply by using what? By finding out the current flowing through this particular 10 ohm resistance, that is, let us say I10, we can find out current flowing through that resistor multiplied by resistor is nothing but the drop across that V2, right? So for that purpose, I have recalled this circuit, okay, because I1 is going to come up to this point, okay, so I1 is going to come at this junction, and then it is leaving into, or then it is splitting into these two directions, right? So I am interested to find out the current flowing through this, let us say these two series connected 10 ohm resistors, because my intention is to find out the drop across this 10 ohm resistors, isn't it? So that's why we have found out the drop across, or the current flowing through this particular, let us say this 10 ohm and this 10 ohm resistor, and it is the series combination is going to result as 20 ohm, right? And because of that, we have applied current division rule, right? So what is the current division rule? Current division rule, let us say we are interested to find out current flowing through this particular 20 ohm resistor. So the total supplied current is written over here, multiplied by the opposite branch resistor, that is nothing but 10 ohm, divided by total resistance where the current is dividing. So 10 divided by 10 plus 20, right? And from that we have found out I1 is equals to 10 by 30. Sorry, I10 is equals to I1 into 10 by 30, right? And because of that, 1 by 3 is coming as 0.33, right? Okay, now if I am going to multiply this I10, whatever the value of I10 that we have observed, or we have received, we have obtained, if I am going to multiply that value with the 10 ohm resistance, then current into resistor, I will be getting the value of voltage drop across that 10 ohm resistor, right? And we did the same, right? So 10 into I10 we have taken, therefore 10 into I10 is nothing but I1 into 0.333, right? And then we have taken that I1 to the left hand side, so I have obtained Z21, and that is nothing but, the value is nothing but 10 multiplied by 0.33, and that is resulting as 3.33 ohms, right? So likewise we have obtained the value of Z21. Is that fine? Okay, now in order to find out other two parameter, what we need to do, we need to set I1 is equals to 0. So once I am going to set I1 is equals to 0, now we are going to modify this circuit diagram from the left to right. Okay, in a previous case we have modified the circuit from the right to left, because this was the voltage source were there, okay, it was there, and now this is the voltage source, okay, and we are going to modify this circuit diagram from left to right now. Okay, so let us do that. Let us go for the step number 3. I hope you understood this. Okay, so step number 3 is what? Step number 3, to find, I think this color is not properly visible, so let us take another color. Okay, so to find Z21 and, sorry, yes, it is Z21 and Z22, let us set I1 is equals to 0, right, by opening port 11 dash. Fine. Okay, so let us do that, and let us redraw the circuit diagram. So I am not going to show this part. Okay, I haven't shown this part, right? Okay, but remember that V1 will not be 0, because it is the drop across this 10 ohm now. Okay, are you getting it? Okay, and this is I2. In previous case we have made I2 is equals to 0, and in this case I1 we have made it is equals to 0, right? But I2 is not 0 now. Okay, fine. Okay, and V1 is nothing but a drop across this 10 ohm now. Is that fine? Okay, now let us do this. Now let us modify this circuit diagram again. Now these two 10 ohm resistors are in series, fine, So let us modify this circuit. So 10 plus 10 is nothing but 20 ohm resistor, right? And that is in parallel with this 10 ohm resistor, and to that 10 ohm resistor there is a voltage source V2. Is that fine? Okay, now let us again find out the parallel combination. So that parallel combination is again resulting to 10 into 20 divided by 10 plus 20. Is that fine? So again it is going to result to as 0.667, right, ohms. Is that fine? So now the circuit diagram will have this kind of structure. So this is nothing but my 6.67 ohm. Is that fine? Okay, now apply KVL to this loop. V2 is equals to 6.67 into I2. So let us take this I2 to the left hand side. So I am going to get I2 V2 divided by I2 is equals to 6.67 ohms, and that is nothing but our Z22. Is that fine? Okay. Now again what we need to do, again we need to find out the current flowing through this particular 10 ohm resistor, right? So we are interested to find out the current flowing through. Let us say now this is the, let us say I10 dash, okay, because we have already used I10, so we cannot use the same suffix or same notation, fine. So for that I have used I10 dash, okay. So let us find out the current flowing through this, let us say 10 ohm resistor, right? Okay, so I10 dash can be found out as I10 dash is equals to up to this point, or let us say this is circuit, the very easy circuit, okay. So up to this point I2 is going to flow, right? Up to this point I2 is going to flow, but after that I10 dash, and let us say this is I1 for example, okay. So this is nothing but the value, right? So I2 multiplied by, we are interested to find out the current flowing through this, let us say 20 ohm resistor. So its opposite branch resistor is nothing but 10 ohm divided by again 10 plus 20, right? So let it be, I2 will be as it is, we don't know the value of I2, right? Okay, and 1 by, that is 10 by 30, isn't it? So okay, so let us take this term over here, fine. So therefore I10 dash is equals to what? It is again 0.333 into I2. Is that fine? Okay, and how to find out V1? Yes, right, we are interested to find out this V1 now. V1 is nothing but drop across this 10 ohm because of this I10 dash, right? So V1 is equals to 10 into I10 dash. Is that fine? And what is I10 dash? 10 into 0.333 I2, right? Let us take this I2 to the left hand side, so it will be divided to this V1. So V1 divided by I2 is equals to, again it is coming as 3.33, right? And this is nothing but my yes, it is Z12. Sorry, I think I have written it as, this must be Z12, sorry. It must be Z12, sorry. Okay, fine. So ultimately now we have found out all the values as, yes, we have found out the values. Z11 was coming as 6.67, right? Z12 is again 3.33, Z22 is again 6.67, and finally we have got Z21 and Z12 values are same. Okay, so remember that whenever you are getting Z12 is equals to Z21, that kind of network is called as a symmetrical network. Okay, so that kind of network is called as a symmetrical network. Okay, so this is nothing but our method number 1, right? Okay, so this is nothing but our method number 1. Let us go for method number 2. Okay, so method number 2, Let us redraw the circuit diagram. All the resistors were of 10 ohm resist value, right? Okay, now check out this one. This is nothing but forming a delta network. If I am going to convert this delta network to the star, then definitely this circuit complexity will be reduced, isn't it? So let us convert this kind of network is called as right now pi network or delta network. Okay, so pi type of connection is there, and we are converting that pi type network into the T network, right? T type of network, that is nothing but the network that whatever we have seen in a previous example, right? So it is having a T type shape. Okay, so what we need to do, we are going to draw now the delta star network inside this delta network, so that it will be easy to find out the particular values. Okay, so let us say this is RA, this is, let us say this is RB, and this is RC. Is that fine? Okay, so let us find out RA, RB, RC. So you know that simply. Okay, so the multiplication of, let us say this point is there, so for this point these two resistors are connected, so 10 into 10 divided by, again 10 plus 10 plus 3 10 is 30, right? So all the values of the resistors will be coming as 100 divided by 30, that is 10 by 3, right? And 10 by 3 is coming as 3.33. Am I right? Yes. So remember that all the values of the resistors will be having value as 3.33. For that, for the simplicity purpose, only I have taken all the resistors of same value. Is that fine? So after modification, my new network will be like this. Am I right? So this is nothing but 3.33. This is also 3.33. Sorry. So this was 3.33. This is also 3.33 ohms. This is also 3.33. Okay, fine. And this is nothing but my line. Okay. Now let us stretch this point to this point, so that this line will become horizontal. Okay, so let us do this. Is that fine? So once I am going to stretch it, then I'll be getting this kind of network, that is nothing but my T network. And this is nothing but the network whatever we have studied or whatever we have seen in the very first example, right? So all the values of the resistors were 3.33, right? 3.33. This is also 3.33, right? And this is nothing but I2, this is V2, this is I1, and this is V1. Okay, I hope the circuit complexity has been reduced, right? So this is a very simplest type of circuit. Remember that even if you are having multiple delta networks ahead of this or in front of this also, you can reduce that delta network to star. Again you can go for the simplification of the network, and you can finally find out this type of T network. That is the very simplest method of applying a Z parameter, or, and that's why I have told you to remember this trick. Okay, so instead of remembering the formulae, you just remember the trick, so that you can apply that tricks and you can easily find out the values of that star delta to star conversion, right? Okay, fine. Now let us find out the Z parameters. Okay, now step number 1 is, again as usual, you need to write the equation. So V1 is equals to Z11 I1 plus Z12 I2, right? V2 is equals to Z21 I1 plus Z22 I2. Then make a open circuit over here, right? So once I am going to make a open circuit over here, this will not be connected, right? So this 3.33 will not be in picture, right? So this was your step number 1. Step 2, find Z11 and Z21 I1 I2 must be 0, right? So let us do this and let us redraw the circuit diagram. Okay, so this is nothing but 3.33. Okay, this is also 3.33. Apply KVL. So V1 is equals to 3.33 I1 plus 3.33 I1. Yes, so I hope it is going to become 6.66. Yes, I1. Let us take this I1 to the left hand side. Sorry, so this is nothing but V1. Therefore V1 divided by I1 is nothing but 6.66 ohms, and this is nothing but our Z11, right? So we have got first parameter. Okay, what is V2? V2 is not going to become 0, though I1 is 0, and V2 is nothing but drop across this 3.33 ohm because of current I1, and therefore V2 divided by I1 is equals to 3.33. So no need to go for again that current division rule and all these things, that bullish things. Okay, so it is nothing but a time consuming process. So sorry, this is nothing but Z21, right? Okay, fine. So we have received, or we have obtained right now two parameters. Let us go for the other two parameters. So let us say, okay, let us go for the next page. Fine. So to find out this is nothing but, let us say, step number 4. To find Z12 and Z22, set I1 is equals to 0. Therefore now this 3.33 ohm resistor, let us say this 3.33 ohm resistor will not be in picture. Okay, so this is nothing but over here, this is 3.33, this is also 3.33, because I1 we have made as 0, but V1 will not be 0. V1 will be the drop across this 3.33 because of I2, right? Okay, so therefore applying KVL, apply KVL. Therefore V2 is equals to 3.33 plus 3.33 I2, right? Therefore it is coming as 6.67 or 6.66 V2 divided by I2, right? And this was the value that we have observed for Z22, right? Okay, so this is nothing but Z22. Okay, fine. How to find out V1? V1 is nothing but drop across this 3.33 because of I2, and therefore V1 divided by I2, I'm getting this as 3.33 ohms, and that is nothing but my Z12. So likewise I can simplify the network, and I can simply find out the values of Z12, Z21, Z22, Z1, Z21, right? Likewise. Okay, so finally I am going to write the Z parameter matrix. So Z matrix is nothing but written as Z11 was coming as 6.66, Z21 was coming as 3.33, this is also coming as 3.33, and lastly 6.66. Is that fine? So once you are going to write this matrix, definitely you will be getting the 8 marks if all the values are correct. Is that fine? Okay, so we'll conclude over here. Okay, and we'll take or we'll proceed into the next lecture. Is that fine? Okay, let us go for the example number 3rd, Z parameter example number 3rd. Okay, now let us go for this one. I hope now you can easily apply this Z parameter to this circuit. Fine. So what is the simplest method to apply this? You need to convert this network into the T network, right? So that is the first step. Okay, so let us say this is a 20 ohm resistor, this is a 30 ohm resistor, 40 ohm resistor, 50 ohm resistor, and 60 ohm resistor. Is that fine? Okay, sorry. Is that fine? Okay, so let us apply Z parameter for this. First we need to go for the delta to star transformation. So let us convert it. Let us draw the star network inside this. Okay, so let us find out the value of this star network. So this is nothing but 30 into 40 divided by addition is what? 30 into 50 is 30 plus 50 is 80. 80 plus 40, it is 120. So remember that the denominator is 120, right? So let us calculate this. 30 into 40 divided by 120, it is coming as 10. So this value, this resistor is coming as 10. Let us calculate this now. 40 into 50, 40 into 50 divided by 120, it is coming as 16.67. Yes, is it? So 50 into 40 divided by 120, it is coming as 16.66, right? And let us calculate this one. 30 into 50, so 30 multiplied by 50 is equals to divided by 120, and that is coming as 12.5. 30 into 50 divided by 120, it is coming as 12.5. Is that fine? Okay, so now this is nothing but a 20 ohm resistor. Let us say this is nothing but 16, sorry, not 16, it is 10 ohm. Then this is nothing but coming as 16.66, right? And lastly that is nothing but 12.5. okay, so this was 60 ohm, this was 20 ohm. Are you getting it? Okay, so let us modify this. Let us stretch out this point up to this, and let me make it a horizontal line. Is that fine? Okay, so let us do that. So this is nothing but 20 ohm series 10 ohm. 20 ohm is in series with this 10 ohm resistor now, and then this is nothing but a 12.5 ohm resistor, right? And this is nothing but, let us say, 16.66, and that will be in series with this 60 ohm resistor, and this is going to result me a final circuit. So let us redraw the final circuit. 10 plus 20, it is becoming 30. Am I right? Okay, this is nothing but becoming as it is 12.5. There is no change into this. And lastly this one 76.66. Am I right? So 60 will be added with the 16.66, so 76.66. Is that fine? Okay, very good. Now apply the Z parameter. Okay, write the Z parameter equation. V1 is equals to Z11 I1 plus Z12 I2. V2 is equals to Z21 I1 plus Z22 I2. Okay, this is nothing but step number 1. Let us go for 2. Set I2 is equals to 0 and find Z11 and Z21, right? So let us go for this. So simply the circuit will be disconnected, that is 76.66 resistor will be disconnected, right? But V2 will not be 0 because of I2, right? Therefore I1 V1, this is nothing but 30 apply KVL. V1 is equals to 30 plus 12.5 I1, right? Therefore V1 by I1 is coming as 42.5, and that is coming as Z11. So this is the value of Z11. Am I right? Okay, drop across this 12.5 is nothing but V2. V2 is equals to 12.5 I1. Therefore V2 divided by I1 is nothing but my Z21 is equals to 12.5. Isn't it so simple, right? Okay, so let us go for the further calculation of. Okay, now step number 4, set I1 is equals to 0 to find Z12 and Z22. Okay, so let us redraw the circuit diagram. Now the 76.66 will be in picture. This was nothing but 12.5, and this resistor will not be in picture, right? So simply it is disconnected because of I1 is equals to 0. Is that fine? Okay, but though we have made I1 is equals to 0, V1 will not be 0. V1 will be drop across this 20.5 because of I2. So let us calculate. Applying KVL, V2 is equals to 76.66 plus 12.5 multiplied by I2. Therefore V2 divided by V2 divided by I2 is equals to coming as okay, 76.66 plus 12.5, it is coming as 89.16, and this is nothing but Z22. Are you getting it? Okay, finally Z12 now. Okay, so V1 can be found out as drop across 12.5 because of I2. Therefore V1 divided by I2 is 12.5. In most of the cases you will be getting Z12 and Z21 same values. Okay, so up till now we have seen all the examples in which the values of Z12 and Z21 were same, right? So these are all the circuits, those are nothing but symmetrical type of circuit. So let me write the Z matrix. Okay, so first value was, let me recall that value, Z11 was 42.5, so 42.5 ohms. This was 12.5 ohms, this is also 12.5 ohms, and finally 89.16 ohms. So once you are going to get this matrix, you will be getting 8 marks. Okay, good. So over here we'll be stopping, fine, and we'll continue in the next lecture. Thank you.